histogram. Now, a stem plot is where you set up. So again, I'm going to use those data values we've been working with. Your stem typically will be something like the tens and the hundreds position. So our stem would go over here, and then we'll have our leaves, which are typically represented as either the part after the decimal point or the units position. In our case, since we're working with numbers in the 60s, 70s, 80s, and 90s, our stem will be the tens position and our leaves will be the ones position. So what I do for my stems, I know that the smallest one can be a 60, 70, 80, 90 based on the grades, again, on those exams. And so as I look through, I see I have an 86, an 81, a 76, a 64, an 81, an 89, a 74, a 90, a 79, an 89, a 76, an 80, a 68, a 90, a 79, a 71, a 78, an 81, and so forth. So I could enter all of the data values into these 4 columns that I have, and what I'd end up with, again, if I turn this to the left so that the stems were at the bottom and the leaves were at the top, what I could see is a shape of the distribution. But the nice thing about a stem plot is it keeps the original data values. I can look back and say, oh, I had a 64, I had a 68, I had a 76, I had a 74. Now, in some of the books where they do stem plots, they actually put the leaves in numerical order. Our textbook does a mixture of the two, just doing them as you get to them, or you can put them in order. I don't care. I will accept it either way. So you can put them in order or you can mix them up. Doesn't matter to me. Now, in terms of doing a bar graph, a Pareto chart, a pie chart, all of these can be done in Excel. And in the sample problems, I will go to Excel and we'll find some examples from the textbook and actually do bar graphs and do Pareto charts and pie charts using Excel. Bar graphs differ from histograms in that the bars don't touch. In histograms, the bars touch because numerically what's happening is you have the same upper boundary for the lower class as the same lower boundary for the upper class. So they actually touch in a histogram. In a bar graph, the bars are separated by spaces, and bar graphs are used for non-numeric data. Bar graphs are used for nominal data, things like colors of cars, political affiliation, that kind of thing. So bar graphs are used for non-numerical data, whereas histograms are used for numerical data. A Pareto chart is a special bar graph that where the bars are arranged from the highest frequency on the left to the lowest frequency on the right. And I can show you in Excel basically how you would set it up so you'd have a Pareto chart. Pie chart is excellent for a case where you have something like a budget and the circle represents 100% of the budget, and then you break it down into parts like you have one section is for food and one section is for housing and another section is for medical, another section is for gas, Another section is for utilities, and then maybe miscellaneous somewhere in here. So that's an excellent type of graph for that. And again, Excel is the best place for producing a bar graph, a Pareto chart, and a pie chart. Now, scatter plots you can do in Excel, but you can also do those in StatDisk. And again, what I will do, I'll probably do it in Excel until I get an updated version of StatDisk. The time series graph you can also do in Excel. So I'll try to show you some examples of those when we get to the sample problems. Now, there are a couple of types of graphing errors that you want to avoid, and one is the graph contains some errors, and two is that the graphs are correct but they're misleading. So the first way to be misleading is to leave, let me just draw a picture and see if you can. Let's do 5,000, 10,000, 15,000. Okay, and men, women, and this is a bar graph. Okay, so when you look at this, and we see that we have 10,000 women versus 15,000 men, it looks like it's a big difference. But notice the graph over here on the left, we'll say number of people. But if we look at a graph where it starts with 0, here it's starting at 5,000. Okay, so 5,000, 10,000, 15,000. And if we do men and women, and the men go up to 15,000, and the women go up to 10,000, it doesn't look like quite as much of a difference. Now, the way I've drawn it, it doesn't look like a whole lot of difference between the two. But in some cases, it does make a big difference in leaving out the 0. So take a look at some examples in the book. They're really better than this particular one that I drew. The other thing that can be misleading is like a pictograph. Say you want a rectangle to represent some amount of money, and you're saying something costs twice as much. So what is done very often with pictographs, since it costs twice as much, okay, so here's our width and here's our length. The person representing twice as much doubles both the width and the length of the pictograph dollar bill. Okay, now the problem with this is that the area of the original drawing and the area of the second drawing, when we multiply 2 times 2, we get 4. Instead of having double the area, we have 4 times the original area. So this bill is not representing twice as much. It really represents 4 times as much. And if you go to 3 dimensions, you even make it worse. Okay, if you have a gold brick or something you're using to represent. Here the volume will be length times width times the height. But what happens if you double each of those? Okay, if you double each one, so you have 2 times the height, 2 times the length, and 2 times the width, what happens to the volume? 2L times 2W times 2H. Our volume is 2 times 2 is 4 times 2 again is 8 LWH. So what's happened? We really now have 8 times the volume of the original figure. So watch out for pictographs. They also can be very misleading because of this factor that very often the person drawing the graph doesn't take into account. So in the problems, in the sample problems, I'll use some of the graphing assignments from the even exercises, and we'll do some of those in the Excel. I'll emphasize Excel in that particular set of problems since I have already used StatDisk and talked about that. So we'll do Excel in the sample problems.